Alright. Okay, so maybe the air got really squished together, right? Got a lot of that squishing going on. What happened? Alright, maybe it got real big in there, right? So, you know what? A lot of you weren't here in the beginning of the show, but we were talking about how we can change the different states of matter. So if you want to turn a solid into a liquid or a liquid into a gas, all you have to do is add heat. The same thing is true if you take heat away. So what we did is that this liquid nitrogen here is so cold, it was able to take the heat and energy away from the gas atoms inside the balloon and actually brought them together, kind of squeezed them together and turned the gas into a liquid. So we actually made some liquid air. And I can prove it to you by bringing out the last balloon. Remember that last balloon is transparent, so you can see right through it. So the liquid that you see rolling around is liquid air. It's the same air you're breathing right now, but in its liquid form.
Oh.
So let's see here. Does everyone see this white liquid rolling around? That's liquid air. That's the same air you're breathing right now. This is this liquid form. It has like this whitish color. And you know, that liquid nitrogen is so cold it's able to turn the air that we're breathing into this liquid. But what's happening right now is that since it's so hot in here, compared to the liquid nitrogen, it's 400 degrees hotter out here than it is in that liquid nitrogen. This liquid air is boiling, turning back into a gas, and as it turns back into a gas, it reinflates the balloon until it's all back to normal. Alright, so that was what was happening right here. But now that you can see the power of the liquid nitrogen, it's so cold, it can turn the air we're breathing into a liquid. I'm going to need a volunteer who's willing to stick their hand in the liquid nitrogen. Alright, perfect. So I got a lot of volunteers. Let me just throw a disclaimer out there, right? So this liquid nitrogen is 320 degrees below zero, 400 degrees colder than it is in this room right now. You think it would be a good idea to stick your hand in the liquid nitrogen? No, definitely not, right? But I like how some people are saying no, but they still have their hands up, right? Now you can put your hands down. Put your hands down, put your hands down. Because I actually already have a volunteer who's going to lend us a hand. Right? And his name is Mr. Hand, right over here. And Mr. Hand is kind of like your hand. Your hand is made up of about 50 to 60% water. Mr. Hand here is filled with water. You got a skin on your hand. Mr. Hand here has a rubber skin. So he's kind of like your hand, but whatever happens to Mr. Hand in the liquid nitrogen would be pretty much the exact same thing that would happen to your hand if you left it in there for just as long. So everybody say bye-bye to Mr. Hand. Alright, see you later, Mr. Hand. And you know, we'll give him a couple of minutes to chill out. And while we wait, let me ask you a question. Your skin, is that a solid, liquid, or a gas?
Yeah.
Alright, so there's definitely some gas in there, very, very little gas. We'd say it's mostly something else though. Alright, so yeah, there's also liquid in there, but we'd say it's mostly a solid, right? There's definitely liquid, definitely gas, but we'd say it's mostly a solid, and it's not the same type of solid as this table or the floor. It's more of a solid like this rubber band. And the different states of matter can also have different properties. In this case, this rubber band has a property known as elasticity. So normally in a solid, the atoms are locked in place. When they have elasticity, those atoms are allowed to kind of slide past each other, causing this to stretch. So what do you think is going to happen to this rubber band if I stick it in the liquid nitrogen? Yes? Alright, so might turn into a liquid. Any other theories, guesses? Your hand up? I'm not sure. Might break, okay. Might get longer. Might heat up. You got a new theory? Shatter? Okay, alright, great theories. Once. Is your hand up? No? Alright. Stick it in here for about 7 seconds. 1, 2, 3, 4, 5, 6, 7. You know what? That liquid nitrogen is so cold it was able to take the heat and energy away from the atoms sliding past each other, and now they're locked in place, kind of like a regular solid. So how do you think we can turn it back to normal? Exactly, just heat it up. And so I can just heat it up with my hand real quick.